Hello, this is a follow-up from the previous video where I talked about differentiation and what a derivative actually meant. I said in the last video that in this video I'll be discussing some terms or some rules and formulae that well, these are the rules. This is the power rule, then the quotient rule, the product rule, and some more formulae. So yeah, that should be formulae or formulas. I guess both are fine. Now let's start off with something known as the power rule. So let me write it bold and big. Power rule. Now you may have noticed that I haven't rubbed this if you have seen the previous video, because this is something which is very important in calculus, and this holds the essence of what differentiation or what a derivative actually is. So it's better, I mean, if you understand it, that's just wonderful. I'll try to explain it more if I get the chance. Alright, so let's start off with power rule. Now, power rule is a very simple rule. It just talks about something like d of f of x divided by dx, which is just like writing dy by dx, as I said in the previous video. Now, if you have f of x is equal to x to the power n, we have d by dx of x to the n, or you can also write it as d of x to the n divided by dx. I prefer this one because d by dx is sort of like an operator in mathematics. So yeah, so basically this value is found to be nx to the n minus 1 power. So yeah, there's a proof for it, which we can prove from this formula, and this formula is just very important. Alright, I already wrote it. So yeah, I hope you understand that it's important. So you can prove it. I'll try to prove it in some other video, but here I'm just stating this rule. And just to reinstate, this rule is very important because we are going to use this in a lot of places in our calculations, and so I'll just I hope you remember it, and it's actually better if you do. So yeah, this is the rule, and this is known as the power rule, where d of x to the n divided by dx is equal to nx to the n minus 1. So just remember that and you'll be good. And yeah, let's move on. So we have discussed the power rule. This is the power rule. Just rub it. Now we move on to something known as the quotient rule. So I'll just write it down. Let's use another color. It's getting too mundane. Let's use green. So we have quotient rule. So what does the quotient rule say? Now, quotient rule is used to find the derivative of two functions. Remember, two functions. Let the functions be f of x and g of x, and when they are divided, we use it to find the derivative. So we have d by dx of f of x divided by g of x, given that g of x does not equal 0, because if it does equal 0, it'll be undefined. So yeah, so how do we find the derivative over here? Now there's a way to find the derivative, and there's a formula which is already given. So we have f of x, so sorry, we have f dash of x times g of x minus g dash of x times f of x divided by g of x whole square. So this is the quotient rule, and that's how we find the derivative when two functions are divided and the denominator function is not equal to 0. Alright, so now the way to remember is it's the derivative of the first function times the second function, or the denominator function, minus the derivative of the second function or the denominator function times the first function or the numerator function divided by the square of the denominator. So yeah, this is also very important because we're going to use this, very important, because we're going to use this in a lot of places in our differentiation problems later onwards, which I'm going to discuss. So yeah, let's move on. So we have covered quotient rule. Let me just increase the size right now. And now we move on to the product rule, and even the product rule is sort of same, but only here there's a product and not the quotient. So we have the product rule now. Now the product rule says that we have the product rule, and the product rule says that we okay, let's say we have two functions, right? So we have to find d by dx of f of x times g of x. Now what is the derivative of this? So the the formula, or actually there's a method to prove it, and I'm not going to prove it over here. We have, if you have to prove it, we have f of x times the derivative of g of x plus g of x times the derivative of f of x. Now, one thing I may have forgotten to discuss is if we have a function like y is equal to p of x, dy by dx can be written as p dash of x, and d square y by dx square, which is the second derivative, which I'm not going to confuse you with now. I may discuss it in another video. Probably I will, because I want to discuss it. It's a really interesting thing. It basically talks about the rate of change of the slope, or I mean the rate of change of the the change of in the y, yeah, I mean in the change in the rise, you could say. So this can be written as p dash of x rate. So that's just a shorthand. We use that to write it, and yeah. So basically, okay, that's the product rule. Now we move on to a very important part, which covers some formulae. Now those formulae are very preliminary or very simple formulae, which you need to remember to solve better, I mean more complex problems in differentiation. Let me discuss them one by one. So we may have something like sine of x. So what is the derivative of sine of x with respect to x? Now, notice I say respect to x because x is the x-axis and y is the y-axis. So basically, we are finding the rate of change in y with respect to the x-axis. So yeah, what is d by dx of sine of x? That is written as cos of x. Now, there's a very interesting way to look at it. That's if we have a graph of sine of x. Let me just draw it clearly because this is really interesting. Now, if we have we have 1 over here and we have minus 1 over here. So this is sine of x, right? Moves on like this, moves on like this. Now the very cool part is that if you have this and you are to find the derivative of this function, so if this is sine x and we have to find d by dx of sine x is equal to cos of x, we essentially get the cos of x graph as the derivative. That's what it actually means. Let me just draw it clearly and I'll try to explain it because it's really interesting. So we have this, and this is 1, and this is minus 1. So notice what this says over here. Over here, the slope of sine x is 1. At 0, the slope of sine x is 1. And that's why the value of cos x graph at 0 is also 1. And let's talk about it over here. We have the slope at pi by 2 as 0. Slope m is equal to 0 at pi by 2. And so at pi by 2 over here, we have the value as 0. Because that's what it means, right? Because this is cos x and this is sin x. And how are they related? They're related by this, that the d by dx of sin x is equal to cos x. So what that means is that every value of x of sin x, whatever is the slope, that is the value of cos x graph at each points of x. That's what it actually means. Alright, so yeah, let's move on. And yeah, so that's d by dx of sin x is equal to cos x. And also, it can be proven that when we have d by dx of cos x, we get minus sine of x. Similarly, we have, if you have something like, let's say, d by dx of tan x, we get sec square x. When we have d by dx of sec x, we get sec x tan x. When we have d by dx of cot x, we get minus cosec square x. And when we also have d by dx of cosec x, we get minus cosec x times cot x. And similarly, there are many more functions. I guess we have covered all the trigonometric ones. There's some important ones also, like d by dx of log of x, and this is log of b to the base e, and that's 1 by x. Now this is very important, and yeah, it's important that you learn it. Also, when we have the exponential function, we have d by dx of e to the x. We have e to the x only, and this is so interesting. It just boggles my mind, and I just love it when this happens, because when we have the graph of e to the x, it looks something like this. Now understand the significance of this. Okay, so when we have 0, this is 0 comma 1. What this means is that the derivative of e to the x of this function is the same function. So basically, even the slope values at all these points will point to the same y values for the derivative. So basically, the slope at this point is the y value. That's what it means, and that is just so interesting. So yeah, it goes something like this. Yeah, and it never touches the x-axis. Yeah, so it's even the derivative of d by dx of e to the x is the same function. And yeah, these are basically all of them, the important ones. I'm going to talk about the inverse trigonometric functions later onwards, but yeah, hopefully you get the gist of it. These are the functions which can be proven with this formula, and I may prove it in a later on video. And yeah, I hope you get this, and in the next few videos, we'll solve some problems. So yeah, put on your thinking caps, alright? See ya.